Do you know that these days our planet has not one, but several moons? Well, kind of. Astronomers have recently discovered another moon orbiting Earth. But it's not what you might be imagining. It's actually an asteroid trailing along beside our planet in a complex semi-orbit. The asteroid was named 2023 FW13, and instead of simply orbiting our planet like the moon does, it orbits the sun. But its orbit is so unusual that it causes the asteroid to circle Earth too, keeping it in roughly the same area as our planet, even though it doesn't orbit it directly. You've probably already realized that 2023 FW13 isn't the kind of moon where we could send a mission. It's way smaller and farther away than our natural satellite. The newly found space object is a mere 50 feet across and is floating 9 million miles away, and that's when it's the closest to Earth. This distance is around 35 times as great as that between our planet and the moon. On the other hand, cosmically speaking, it's just next door. For the first time, the quasi-moon was spotted by astronomers at the Pan-STARRS Observatory on Haleakala in Hawaii in March 2023. Now, a quasi-moon is a space object which shares a similar orbital path with a planet, even though it doesn't orbit this planet directly. Plus, it has a steady relative position to this planet. True moons always keep a relatively consistent distance from their parent planet, but quasi-moons have more complex paths. That's because of the combined gravitational influences of the Sun and the planet itself. Quasi-moons usually have horseshoe or tadpole-like orbits. To put it simply, you can see them travel ahead or behind a planet when it orbits the Sun. Such an orbit is truly unusual, and it occurs because the gravitational pull between the Sun, the planet, and the quasi-moon results in a complex dynamic, leading to a delicate balance in the trajectory of the quasi-moon. When a quasi-moon moves ahead of a planet, it tends to slow down with time, and in the end it falls behind because of the gravitational influence of the planet. Similarly, when a quasi-moon falls behind at first, it later starts speeding up and begins to move ahead of the planet. This is what creates that horseshoe shape if you look at this dance from a fixed point in space. At the same time, the orbit will look like a tadpole from the perspective of the planet. Scientists love quasi-moons because they present great research possibilities. Their interesting orbits make them perfect for studying gravitational influences and the intricacies of space mechanics. Plus, they're usually close to their parent planets, which can also offer insights into the formation and evolution of planetary systems. And who knows, maybe at one point in the future, they'll help us with space exploration. Missions to such quasi-moons could give us important information about different celestial bodies and help with the exploration of the solar system. But let's get back to our tiny moon. While it's still being studied, current data suggests that 2023 FW13 entered its current orbit at least 2,100 years ago. And according to simulations based on preliminary orbital calculations, the quasi-moon will accompany Earth for another 1,700 years or so. The good news is that the asteroid won't end up on a collision course with Earth, despite traveling relatively close to our planet. A few years ago, another asteroid was pulled into Earth's orbit and started to travel along with our planet. No larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it became our temporary mini-moon. It wasn't going to stay with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. 2020 CD3 will make another close pass to Earth in March 2044, though it will most likely not be caught by Earth again because of the greater approach distance. Temporarily captured objects, such as this one, are rare. They need to have a specific direction and speed to be captured by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. And in 2016, astronomers discovered another space rock and called it Kamo'olelewa. There was one absolutely amazing thing about this space traveler. Astronomers suspect that this celestial body could have formed after splitting off the moon during an ancient collision with an asteroid. Yes, it means it might be a piece of our moon. When specialists examined the space body and analyzed its composition, The results didn't match any of the more than 2,000 near-Earth asteroids studied before. Kamo'olawa was too tiny and too far away for regular telescopes to study it. That's why the researchers had to find a more powerful telescope to learn more about this unusual find. After using the Large Binocular Telescope, one of the largest optical telescopes in America, and the Infrared Lowell Discovery Telescope, the scientists finally figured out what the asteroid was made of, and what they had discovered surprised them. The asteroid had light spectra similar to those of the samples of lunar material delivered to Earth by the 1960s and 1970s Apollo missions. Astronomers admit that there might be other asteroids with the same spectra, but so far they haven't found anything like that. Kamo'olawa is another quasi-satellite of our planet. Its orbit is a bit tilted and slightly elongated, so the rock keeps leaping ahead and then falling behind Earth. In other words, it performs constant loops around us. At its closest, the 130-foot-wide asteroid gets to the distance of around 40 times that of the Moon. According to the results of orbital analysis, the rock has been following Earth for at least 100 years. We found more than 480 lunar meteorites on our planet. It may mean that pieces of our natural satellite travel through space pretty regularly. And Kamo'olawa might as well just be the first discovered large rock split off the Moon as a result of an ancient collision. Now we've already talked about quasi-moons. Let's find out more about asteroids. These space bodies are often called minor planets or planetoids. They're usually rocky leftovers from the early formation of our solar system that occurred around 4.6 billion years ago. They are mainly found in the asteroid belt between the orbits of Mars and Jupiter. Asteroids can be very different in size, from tiny dust particles and modestly sized boulders to huge bodies reaching 600 miles across. Asteroids often have irregular shapes, especially smaller ones. At the same time, large space bodies can have more of a spherical shape. Unlike planets, asteroids don't consist of layers. They're made of different kinds of metals and rocks and have no atmosphere. Funnily enough, some asteroids have moons of their own. And there are even asteroid binaries where two asteroids of similar size orbit each other. The asteroid belt located between the orbits of Mars and Jupiter has the largest number of asteroids in our solar system. There are millions of space rocks there of various shapes and sizes. But despite such a huge number of asteroids, they're widespread across the vastness of the cosmos. And if you accidentally wandered into that region, the chances of your spacecraft colliding with an asteroid would be quite low. But even though most asteroids prefer to stay in the asteroid belt, some of them make their way closer to Earth. Those are called near-Earth asteroids. Experts monitor such asteroids because of the potential risk they pose. In the past, they did affect our planet. Think of that large one that most likely wiped dinosaurs off the face of the Earth. NASA and other international space agencies have sent a few missions to research asteroids. Some of them aim to retrieve samples from asteroids and return them to Earth for study. The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The Moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the Moon suddenly became brighter than the Sun? Let's explore several scenarios. Scenario 1. If the Moon becomes brighter than the Sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon, and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon. Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull, so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth. Imagine several of those affecting our home, but that's a topic for a completely different story.
The Moon is the Earth's closest neighbor in space, and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. This catastrophe turned Earth into a scorching ball of molten rock, and it also pushed some material into its orbit, eventually creating the Moon. Now, this heavily cratered sphere revolves around our planet, causing the high and low tides we enjoy around the globe. A bit more than 1/4 the size of Earth, it is the 5th largest natural satellite in the solar system. The Moon has several phases, for example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But now, imagine waking up at night, looking up into the night sky, and noticing that the moon looks a little different than usual. Looks brighter and bigger. The difference is so slight, you assume you're just seeing things because you're half asleep. You go back to bed, blissfully unaware that instead of the moon, you've just seen Mercury. At first glance, this planet, the nearest to the sun, is similar to our natural satellite. Its surface is also littered with craters left by space rocks. But Mercury is around 2/5 the size of our planet, so it's a bit larger than the moon. This would mean a greater impact on our planet. Nights would become brighter, high tides would become higher, and low tides, you guessed it, lower. The lunar cycle, that's the time the moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement would not have any drastic consequences for our planet. Alright then, how about Venus? What if we instead swap in the 3rd brightest natural object after the sun and the moon? Venus is often called Earth's sister planet because their mass and size are nearly the same, and that would make a difference. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the moon's surface. The morning star, as it's often called, would be much brighter than the moon. For one thing, it generally reflects 6 times more sunlight, but it would also occupy at least 16 times more space in the sky. That's why nights on Earth would be way brighter, as bright as early twilight now. If you looked at Venus from this distance, you'd even be able to make out the vague swirling patterns on the planet's yellowish-white cloud cover. But Venus wouldn't really become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric. Like me! But if Venus moved in the same speed as the moon does now, the two planets would eventually crash into each other. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the moon, it would also be hard to ignore. The planet's disk would emit a reddish hue, and it would be almost twice the moon's size. Even without a telescope, you'd be able to marvel at its unusual color and the dark spots on its surface. And even if you didn't see the red planet, you would still feel its unusual effects on ours. Mars is half the Earth's size, but several times larger than the moon. Replacing a smaller space body with a much larger one would increase the gravitational stress, upsetting the delicate balance on our planet. If you were unlucky enough to be at the seaside when Mars took the moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would also reflect more sunlight than the moon, thus illuminating the night sky. However, this time with an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically. But with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would be literally next door, voyages to it would become a whole lot more feasible. Pack your bags, kids! Okay, now for the big one. If Jupiter replaced the moon, Earth would immediately lose its status as an independent planet. It would instantly turn into yet another moon of the largest planet in the solar system. But hey, at least people would have a beautiful sky view, right? Jupiter is dozens of times larger than the moon. A gigantic, beautifully striped, swirly sphere would cover nearly all of the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, you wouldn't have much time to enjoy the view, as the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn towards Jupiter, which would break the planet apart. It would be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. On top of that, Earth's speed is only 10% of what is needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Now, the rest of the planets on the list are smaller than Jupiter, but they're still ridiculously huge, so from here on out, expect to see similar results. But if Saturn was to replace the moon, it would truly be the most beautiful skyline to behold. I'm a little biased because Saturn is my favorite planet. It's more than 35 times larger than the moon, so it would cover 18 degrees of the sky. And its rings would stretch even further, from horizon to horizon. At the distance the moon currently is, Earth would be a bit further away from Saturn than its own moon, Dione. And again, since Saturn is way more powerful than our planet, Earth would once again turn into a satellite. And again, Earth's rotational speed wouldn't be enough to keep it up in orbit, so we'd most likely crash into it in a day or two as well. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and fragments of moons that shattered millions of years ago. It wouldn't be an easy feat to get through all that space debris. Plus, our planet would have to avoid all of Saturn's moons, all 53 of them. Does anyone know how to fly this thing? But even if Earth did somehow stay up in orbit and turn into Saturn's 54th moon, the gas giant's gravitational pull would still lead to massive tectonic shifts all over the globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Next up, twins. Uranus and Neptune are both ice giants. They are the same size, larger than Earth, but still smaller than Saturn or Jupiter. They both have icy interiors, deep atmospheres, and a similar color, a very mystifying bluish green. So if either of these planets replaced the moon, the consequences would be the same. So let's flip a coin. Okay, let's say that Neptune is the one you'd see in the sky one day. Neptune is 14 times larger than the moon. The planet would look like a bright blue hot air balloon in the sky, not only at night, but during the day too. It would appear to be 15 times larger than the sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the sun would vanish behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half, as opposed to our measly 7 minutes and 32 seconds with the moon. Neptune has 17 times the mass of Earth, so its gravitational pull is much stronger. That's why our planet would instantly become, say it with me now, a satellite. It would orbit Neptune at about the same distance as its own largest moon, Triton, only slightly further away. This means there would be a great risk of Earth colliding with Triton, which probably wouldn't go too well. But let's assume we were lucky enough not to cross paths with Neptune's satellite. Even so, there would be more than enough problems on our hands. For example, tides in our planet would become 1,000 times more powerful than those caused by the moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat it up significantly. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably bork up the internet too. But of course, the most dramatic scenario would happen should the moon get replaced by the sun. See for yourself. The distance between Earth and its natural satellite is about 240,000 miles. But there are between 28 and 43 million miles between the Sun and Mercury. Even though this distance is huge, Mercury is still a scorched, deserted land. It experiences enormous temperature differences, from minus 280 degrees at night to 800 degrees during the day. So I'm sure it's no surprise to learn that if the Sun would suddenly appear as close to the Earth as the Moon is now, it would instantly burn everything off the planet's surface. You wouldn't even have a millisecond to wow at the blazing ball of plasma engulfing the whole sky. I'm afraid sunblock's not going to cut it this time. Typical solar flares are much longer than the Earth's diameter. Just one of them would be enough to melt the Earth's crust, burn its atmosphere, and wipe all forms of life off the face of the Earth. And then our blazing piece of molten rock would immediately be pulled in by the sun and vaporized on its surface. Fun! So, what do we learn from all this? More than anything, I think it highlights just how lucky we are to have the moon exactly as it is, exactly where it is. To try to replace it with anything else would only spell catastrophe for us here on Earth, sooner or later. Thanks, Moon!
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be alright. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into two equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into two parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, Moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends."
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the Sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the Sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. 25 light-years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous. This star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667 cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667 cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world which is more than twice as large as the Earth, lies in the habitable zone of its host star, but it's unclear whether it's liquid, gaseous, or rocky. Kepler-69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler-69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours, but since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler-452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler-425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but two criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth, but since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super-habitable. Another potential super-habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, you can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because, how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away. But Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the two larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered 2 worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits.
The Hubble telescope orbits our planet, looking out at the big unknown universe. Since it's out of our atmosphere, the Hubble can see way further than telescopes on land. No clouds up there. This guy helped us confirm the theory about supermassive black holes in the center of galaxies. It also discovered a whole bunch of new galaxies, including the world's oldest one, which is about 8 billion years older than our own. But let's travel 25 light-years away to another special star, Fomalhaut. It's one of the brightest stars in the night sky, and it's in the constellation Southern Fish. It's almost twice as big and heavy as the Sun. If you look at it from far away, you can see a bright yellow disk around it. It's a debris disk full of bits of space rock, and it's huge. Its width is about 25 times the distance from the Earth to the Sun. Scientists were curious about it. Was all this space dust going to get smushed together and become a planet one day? But then they saw something else. Right there, through all that debris, was a massive, mysterious object. A large yellow dot orbiting the star. It looked like it was skating around a cosmic ice rink. So, in 2008, scientists announced they had discovered an exoplanet called Fomalhaut b. It was the first planet outside of our solar system that we could actually see with our own eyes. It's hard to know how heavy it is, probably like a couple of Marses put together, and it lives pretty far from its host star, about 4 times the distance from the Sun to Neptune. 1 year on the planet would be the same as 1,700 Earth years. We'd all be babies over there. So, one question. Does the planet even really exist? Scientists sat around arguing about it. Then, in 2012, the trusty Hubble telescope came up with some new data. It was real all along. If it was a gas giant like Jupiter or Saturn, that would make it incredibly young, 10 times younger than Earth. And all that dust around it seems to shine non-stop. You'd have to wear sunglasses 24/7. But now, it's disappeared again. Nothing but a donut of debris. So, maybe it was destroyed by a giant asteroid, like the one that wiped the dinosaurs off the face of the Earth. Or it may have been crushed by a rogue planet. These are planets that fly around the galaxy without a clear orbit. Maybe the dust is all that's left from a head-on collision. Or maybe something went crazy in the planet's core, and it exploded from within. Scientists now believe that Fomalhaut b was never actually a planet in the first place. It was just the leftovers of 2 big rocks smashing together. From far away, that kind of massive collision would actually just look like a yellow dot. These 2 colliding space rocks must have been at least 125 miles wide. That's like DC to Philadelphia wide. But this isn't the first time a planet's just up and disappeared from view. Scientists thought they'd found an Earth-sized planet orbiting our neighbor, Alpha Centauri. They called it Alpha Centauri b. Not exactly flashy. Plus, in the end, it turned out it didn't exist. Oops. Scientists make mistakes, just like the rest of us. Not long ago, they thought there might be life on Venus. They found traces of a special gas, phosphine, which can be a sign of life. It was the top story for a month. But then, someone decided to double-check the data. There was some phosphine floating around, but not nearly as much as they thought. Travel back in time a couple of hundred years, and you can find even sillier mistakes. Back then, people believed that the Sun revolved around the Earth, and that our planet was the center of the whole universe. That's because they didn't have fancy equipment to measure stuff. People saw the Sun rise in the east and set in the west. That was enough to say that the Sun revolved around us. So, what happened to that planet? Basically, the Hubble took a photo of the whole star system, but since it's so far away, the photo came out kind of blurry. Scientists just saw a large yellow dot and assumed it was a planet. Scientists don't usually get photos of far-off planets. They normally have to use math to find them. Space objects are in a constant dance with one another. The dance gives off a lot of energy, like gravitational energy and light energy. It's like this. Say your friend is hiding behind a corner. You can't see him, but you can see his shadow on the floor. It's kind of like what scientists do when they look out into the stars searching for planets. So, big deal, a planet vanished billions of miles from here. But what if our perfectly balanced solar system were to lose one of its planets? You better believe it would affect our lives. Mercury's up first. Good news, it's too small to have a gravitational effect on our planet, so we wouldn't even notice if it went missing. Next in line is Venus. This hot planet is sometimes called Earth's twin sister. It's completely uninhabited, of course. Other than that, Venus is one of the brightest spots in our night sky. Pull it out of the solar system and whoa, it's much darker at night. But still, not exactly a big deal. Mars. Life without Mars might even be good for the Earth. There's an asteroid belt between Mars and Jupiter. Mars's gravity can grab an asteroid from the belt, spin it around, and catapult it toward us. Without Mars, the asteroids would stay in place thanks to Jupiter's gravity. Jupiter's heavier than all the planets in our solar system combined. It holds back the asteroid belt, and its gravity is actually strong enough to affect the Earth. A couple of thousand years after it disappears, we'd notice big changes. We'd move closer to the Sun, which means a couple of things. 1, we'd have much hotter weather all year round, and 2, our days, weeks, and years would be shorter. Saturn, Uranus, and Neptune are all too far away for us to notice if they go missing. That just leaves one. No, not Pluto. What if the Moon disappeared? Basically, chaos. The Earth would tilt even more than it already does, and the weather worldwide would go crazy, even crazier than now. It might even lead to a new ice age. The Earth would start spinning a lot faster, so instead of 24 hours in a day, we might have anywhere between 6 to 12. And even though nights would be a whole lot shorter, they'd also be darker than ever. When we see the moon, we're actually seeing the sun reflecting its light off the moon, and even a new moon is usually the brightest object in the night sky. If the sun were to disappear from our sky, it would be pretty much game over. This star is the center of our whole solar system. Without it, the orbits of all the planets would collapse, and we'd move around in complete chaos. The Earth, the Moon, and all the other neighboring planets would just shoot out into the universe, heading for, well, we just don't know. Daytime would be a thing of the past. We'd need the sun for that. So it would be nighttime forever. We'd probably never see the moon again. We'd probably never see anything again. The Earth would get colder and colder, and all the water on the planet would gradually freeze. But what if the sun turned into a black hole? We might still orbit around it. Hopefully, we're far enough away from it to stay safe. Mercury and Venus might be swallowed up, but we might get lucky. So we'd stay where we are, but we wouldn't have the sun to warm us. If it happened slowly enough, we might be able to adapt. We'd need a new power source, a new light source, and plants would have to adapt to get their energy from somewhere else. We'd probably need to build a huge tent-like thing over every city, forest, ocean, or we might just jump ship and move to another planet. Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. and a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit, and at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now, it would become much harder to send our spacecraft there, So it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
If the sun decided to stop producing light, then the animals in the wild would be the first to notice. Most animals need daytime to roam from place to place, especially in the large savannas in Africa. Zebras, wildebeests, and giraffes all need the day to move to avoid predators. As soon as the sun goes down, it's their bedtime. If the sun suddenly went dark, animals wouldn't comprehend what was going on and would simply become an early lunch for predators. Nocturnal creatures would be equally confused at the time change. Birds usually flock during the day, so we wouldn't hear or see any of them. We have them to thank for eating pests in the sky. Well, them and bats. But if you're in an area with no bats, then consider the insects to be the winners here. Temperatures would start to drop gradually. Humans would notice the effects as well. We're used to having the sun shining at the peak of noon, but with the sunshine's disappearance, we would be living in total darkness. It'd just be a matter of survival. If the sun suddenly got dark, then we'd only have around 8 minutes to enjoy the rest of it. That's because it takes that much time for sunlight to travel thousands of miles across the solar system. We would have to use UV lights to grow some crops, but it wouldn't be enough to feed the whole world, not to mention the dropping temperatures across the world. Survival would be difficult in the open plain. Everyone would have to duck inside shelters and warm bunkers. Plants need photosynthesis to grow. Without it, we wouldn't have any crops. Bread wouldn't exist, since it needs wheat. Even the algae in the oceans need photosynthesis to survive, which is the highest source of oxygen rather than forests. This means oxygen levels would start to deplete. Large bodies of water like lakes, oceans, and seas would also start to lack oxygen to sustain marine life. One of our main sources of vitamin D is the sun. There are other ways of getting it, but the sun is the best and most convenient way. Without crops or vegetation, all the herbivores would have to rummage for the last green grass on land or a leaf hanging from a tree. They would soon run out of food, which would also be bad news for us humans, since we need animals like cows, horses, and sheep for our livelihoods. This wouldn't happen overnight. Of course, the oceans would remain warm for some time, but eventually, they would get cold and freeze. Earth is still a planet powered by an iron core that produces so much heat. This would not be enough to keep the planet warm. Our next step would be finding the right shelter and keeping warm. If this happened overnight, then chances are there wouldn't be any ready-made bunkers for a scenario like this, unless you're watching this video and decide to build one after. They would have to provide heat 24/7 and be capable of growing crops under UV light. Solar-powered facilities would be a thing of the past. People would have to wear sustainable suits when venturing out into the open. Since it would be so dark, we would need strong lights or powerful night vision goggles to see anything. The lands would be desolate. Nocturnal creatures that can handle freezing temperatures would take it over. Structures would collapse, since there would be oxygen depletion. Concrete needs oxygen to remain intact. The bunkers themselves would have limited oxygen as well. We would need to uproot many trees and place them under strong UV lights for them to produce oxygen. In turn, it would produce its ecosystem in the large underground bunkers. The oceans on the surface would freeze over eventually. Gathering any natural resources from the ocean floor, like gas or oil, would be impossible. The large object, which used to be a bright and sunny star, would still be floating around. But what would happen if the sun disappeared overnight? Well, pretty much the same thing, except way worse. The sun is the largest celestial object in our solar system, which keeps all of our planets lined up the way they are. They orbit around the sun, minding their own business. Without such a large object keeping them steady, the planets would start to float around randomly. Some might even collide with each other. In other cases, the planets would just float around and fly off into space eventually, until they found a new star to orbit around. Earth might or might not be one of those planets. Our planet would still be dark. We would be flying through space at an unusual speed. The planet wouldn't rotate on itself, and many objects would crash into us. We'd be in the trajectory line of mass comets waiting to strike us down. The threat of the cold wouldn't be a major factor anymore. It would be what's beyond us. This means we'd have to dig our bunkers deeper. We wouldn't have an atmosphere anymore to trap any form of heat or anything. We would be floating for an eternity. But let's go back to that scenario where the sun just decided to go dark. Don't worry, our planet would still be orbiting the sun along with the other planets. The temperatures would keep plummeting until nothing could survive on the surface. It would be total darkness 24/7. Only bacteria and possibly tardigrades could survive on the surface. Tardigrades are microscopic critters that can survive just about anything, including outer space. Eventually, oxygen would be absent from the Earth's surface, and there wouldn't be anything up there anymore except for them. Since they would be the dominant and possibly the only creatures on the surface, they'd manage to evolve into bigger species and produce many more. Hundreds of thousands of years into the future, humans would have had to evolve to the conditions underground. Our eyes would be much bigger to take up as much light as possible. Our skin would become whiter since there would be no sun underground. Our hearing would also be much more sensitive since the underground would create echoing sounds. We'd still have the intellect we do now, but our bodies would be ready for the surface. The main threat would be the giant tardigrades sluggishly dragging themselves around. Under a microscope, they look kind of cute, but imagine them the size of a polar bear. Still want something like this in your backyard? They can live anywhere, so they'd infiltrate the bunkers now and then. They'd get ferocious and come in different sizes and shapes. At this point, humans would not be the dominant species, since they'd have to hide underground. Some tardigrades from different tribes wouldn't be friendly with each other. Major cities that used to be bustling with people would be home to giant water bears. Tardigrades are known as water bears since they kind of look like little bears, but these beasts with 8 legs would be much bigger than them. Bears and most animals would have been wiped out on the surface. Under the ice, some deep-sea creatures would thrive and have moved closer to the surface. These animals were used to living in darkness away from the sun, but over thousands of years of dominating the waters, they'd have grown to enormous sizes. Some of these creatures would adapt to crawling out of the mainland. Even though the surface would be frozen, they'd still find ways to crack through the ice and make their way. Humans, meanwhile, would create large underground channels and networks, building cities and colonies. We'd dominate the tunnels where our hands and feet would grow to become web-like and large. We'd take over everything underground and remain the smartest species on Earth. We'd manage to keep old art pieces from the surface and important records to stay as human as possible. We'd keep on surviving no matter what. You're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott's South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the Moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets.